Hi, in this section we are going to be seeing about two ensemble methods called bagging and boosting. We already saw an ensemble method like random forest, and similar to random forest, bagging and boosting are also ensemble methods in that you go and build multiple models using the same data set, and then you take a vote among these models when you're trying to predict. The difference between bagging and boosting is how do you build this data set for every model that you build. That's the only difference, and we are going to see how exactly they differ in terms of the data set that is being selected. So bagging is called bootstrap aggregating, and it is an ensemble method. And it always uses a base classifier like a decision trees or a naive Bayes or regression. It always uses a base algorithm, and using that algorithm, it is going to do multiple rounds of training, and it is going to build multiple models. And prediction is done using each model. So whenever there is prediction needs to be done, that prediction is done using each of the models. So if there are n models, you are going to produce n results, and then you take a vote among these n results to see which one is the best result. So the way you select data set for each of the round of model building is that for each round of model building or the training, you build what is called as a bootstrap replicate data set. So how do you build a bootstrap replicate data set? Is that if the original data set as m examples meaning m number of rows, you do n rounds of sampling on the data, and for each of the sampling round you select m by n examples. So suppose your original data set has 10 rows, and then you do n rounds of sampling. Let's say you do 2 rounds of sampling. In each round of sampling you select m by n, that is 10 by 2, 5 examples each. So you do 2 rounds of sampling, and each round of sampling you get 5 examples of 5 rows. Then you put those 2 sets of 5 rows together to form the data set. So the final data set also has the same number of rows as the original data set, except that there is a possibility that some values could be repeated. So we will see how that is done in the next slide. Suppose, let's say we want to run training 5 times, which is we want to run training 5 times or build 5 models on a data set. Let's say that data set has 8 records. So how do you do that? And for each round we want to do 2 sets of sampling, and this is called sampling with replacement. Why is it gets called sampling with replacement is that when you pull a sample out of the overall population, you put the sample back. So the next time you sample again, that row you pulled earlier can actually occur again. That is what called sampling with replacement. And how do you do that is, let's say for training round 1, the record IDs for these records are 1 to 8. So when you do sampling round 1, you select 1, 4, 5, 7. When you do sampling round 2, you select 2, 4, 6, 7. So the same rows can occur again because you are doing sampling with replacement. You sample and replace it back in the original data set, so you might be getting the same values back. And then you put sample 1 and sample 2 together to create what is called the bootstrap replicate. And as you can see, some of the samples are repeated. The rows 4 is repeated, and the row 7 is kind of repeated, and this forms your data set for training round 1. Now you will go and do training round 2 and repeat the same process, in which you might get another 2 set of samples, another 2 sets of values. You again form the bootstrap replicate. Some values might be repeated, like the values 2 and the value 6 are repeated, and then you go build the model again. So you will repeat like this for building 5 different models, and whenever you want to predict, you pass the data through these 5 different models, and then you're going to take a vote on which results occurs the maximum number of times. Things to note about bagging is that it might produce improved results than the base classifier. The base classifier is the base algorithm, which you typically run only once, but in bagging you are using the same algorithm to run many times on different data sets. If the base algorithm is providing you unstable results, which is you try to run the algorithm again and again on the same data sets, it keeps giving you different results. In those cases, the bagging is a better option when you use the same base algorithm and then apply the bagging concept onto it. It has high resource requirements. It takes longer times to build models, obviously, because it is going to be building multiple models. And there are various models available in terms of bagging, various implementation of bagging available, and they all use a different base classifier. And here are some examples like AdaBag, bagged cart. Bagged cart is using decision trees. Bagged flexible discriminant analysis. It is a very flexible discriminant analysis is a variant of linear regression, and then you apply bagging on it. Logistic regression, you can do bagging. There is another called model average neural network. It is a variant of neural networks onto which you apply bagging. Please note that the algorithms that are available in the world, even though some of the basics are the same, there are a number of variants that keep coming out and coming out. A lot of research is going on in terms of trying to produce newer and newer algorithms, and these are typically variants of the original algorithm. So you will see like tons of these algorithms available. And how do you know which algorithm is best for your use case is simply by doing trial and error. Use the algorithm and see if the algorithm is predicting better. So you would see a lot of these algorithms, but don't worry about any of them, because all you have to do is choose the algorithm and call the method with the parameters, and it is going to do magic for you. The next thing you are going to be looking at is boosting. So boosting is also very similar to bagging. It is an Ansible method. The only difference between bagging and boosting is how do you come up with the data set for the training process. So it again creates multiple models. Again, prediction is done on multiple models, and then the results, you take a vote to deliver the final prediction. In this case, the difference is that you assign something called weights to each of the samples. So your data set contains a number of records, and each record is given a weight. So typically you start with all records being a weight of 1, and then what you do is, as you keep going and building models, you keep increasing the weights of the records. How do you increase the weight of a record? You can simply duplicate the record. Suppose a data set has 8 records and you want to increase the weight of the third record, simply duplicate it. What that means is now you end up with 9 records. With that particular record, when it gets duplicated, its values, the values of various variables in that record, get higher weightage because it occurs more number of times, and typically that will influence the machine learning algorithms a lot more. So that is how you kind of increase the weight of a particular row or a particular sample. So how does weight is being used is that as you keep doing multiple rounds of predictions, as misclassification happens, you would just increase the weight of those misclassified records. And how do you do that? Let's look at in the next slide. So again, here there are multiple rounds of training. You start off with the weight of all records being equal in the first round. So you don't take a subset, you take all the records and all the weights of all the records being equal. So go and build your first model. Once you build your first model, try to find the in-sample error of the model build. What is in-sample error? Is trying to use the model to predict the training data set itself and see how many of the records are wrongly predicted. If a record is wrongly predicted, means it is not modeled enough in the model that was being built. So you go and increase the weight of those misclassified records. You increase the weight of those misclassified records, like as I said, add a duplicate of that record, and then now you have another data set with the newly added record. Now that data set becomes the input for the second round of modeling. Now you go do a modeling again on the new data set, again find the in-sample error, find the misclassified records, then increase the weight of the misclassified records. Now go for round 3, round 4, round 5. So as you keep building these models, and each round of the model being built, you keep increasing the weight of the misclassified records. So each of the model that is being built uses a different data set and with a different weight for the misclassified record. You ultimately end up with n number of models. Once you have the n number of models, the prediction process is the same as like bagging. run your thing through multiple models, come up with a vote on the results, and then that is your final prediction. Things to note is that they have high resource requirements similar to bagging because they take longer time to build models, and that is because you're building multiple models. The good thing about it is you can use a set of weak learners. Weak learners is nothing but weak predictors. You have a set of predictors. Suppose you do your original correlation analysis and you find that the correlation is weak for all the predictors. So this might be a good option to go and try and see if you can use a set of these weak predictors to actually come up with a strong predictor. So when a normal algorithm might not work well, possibly boosting can actually work well. So it is one good thing to try if the prediction, if you see that the correlation coefficients between the predictors and the target are not that good. It reduces bias because whenever there is misclassification, it gives weightage. So the bias the algorithm originally had on the other rows is kind of reduced. So it manages bias very well. And again, there are different implementation of these algorithms available, like boosted classification trees, boosted GAM, boosted linear model. A number of variants of these algorithms are again available. Again, which one is the best, you have to try and see, and you basically learn from experience as to how do you use these algorithms. Thank you.